YouTube channel. This time around we will be discussing on parametric tests. Non-parametric tests, in which case we will be dealing with the chi-square test. When do we use a chi-square test? A chi-square test is used when our data of research assumes frequencies which are discrete. When the frequencies are discrete in nature, for our data which we are doing a study on, then in this matter, or rather in this case, you can use a chi-square test. Now, in doing such a measuring, you find that the test is as weak as that of a nominal scale. I want to believe that you understand what you mean by the scales of measurement, whereby you start with the ordinal, the nominal, the racial, then we have the other one. So, in my case here, having my hypothesis, that is my null hypothesis, also called the hypothesis of no difference, and the hypothesis states that there are no differences. There are no differences between the groups. There is not any significant difference between the group and the categories in the groups, and therefore we measure our null hypothesis by the chi-square given by summation from I equals to 1 to R, summation j equals to 1 to k, or I j minus I e I j, all this squared over e I j. Now, what do we mean by O I j? First, let us understand that this chi-square has degree of freedom, in which case here our degree of freedom is given by r minus 1 times k minus 1, whereby the r represents the rows and k represents the columns, in which case when I talk of columns I mean the groups, and when I talk of rows I mean of classifications. Remember, we are classifying our data according to groups. And therefore, how many classifications do you have? If you have R classifications, then you will have a degree of freedom given by R minus 1 times the number of groups minus 1. And therefore, when we go back to our formula, let us see what we mean by the whole ij. Now, the whole ij, this is the observation in the height row of the jth column. When we come up with our contingency table, if this is my contingency table and then this is my first observation, this will be first observation 1 in the first column, or the expectation, not expectation, the observation, the first observation in the first group, the first observation in the first group. Now, the second one will be the second observation in the second group. The second observation in the second group. In other words, we are talking, I'm sorry for that. The first observation in the second group. Now, this is the group. This is the classifications. Let me now go back to my formula and explain what we mean by Eij. The Eij in this case represents the expectation in the what are we expecting from our null hypothesis. This is the expected observation in the jth column and height row. How do we get this? We get this by checking the marginal totals relating to each objective, this product of the marginal totals divided by the total. Let me show by an example and you will get it better. I want to use a data whereby I want to measure and test my hypothesis if the education level depends on gender.